particularly over the weekend. So I had, last week when I tested it, I had $9 for a single transaction. I don't know if you had any records, gas costs wise, maybe this could result in a bonus point. In any case, thank you so much. And I guess this was also for in case you haven't used XDAI, in case you haven't transferred DAI or used an exchange, perhaps this was also a good crash course of the great things we have in the ecosystem and also the challenges we are meeting. I talked with Wassily today. They launched a new contract, and you can imagine all these transactions sum up to significant amounts once you want to make any changes in your product, not to mention tiny transactions. Okay, thanks a lot for staking. Okay, Danilo. Hey, Octopus, hello. 1, 2, 3.
Yeah, I've started recording minutes ago, just for the disclaimer.
Okay, cool. All right, then we can start. So let's check our agenda first. We will have 2 presentations today. One is Marc providing an overview on the Gitcoin Grants cadCAD model. And the second one is Jan with, giving us a good overview on the Gitcoin Grants data available for this research. I think, Jan, any issues here? Screen sharing is okay?
I haven't tried yet, but let's hope for the best.
We cross fingers and start with Marc's presentation anyways. After that, I think presentations will take around 10 minutes. Then, of course, we reserve time for questions. So note your questions and let's dig into that so that we all have a good understanding of the cadCAD model and the data available. And then second, after, half an hour, 45 minutes, we'll start with a workshop. And this is about discussing potential research questions. We'll try to nail the most promising one and form teams if you wish. As mentioned, you can work individually, you can work in teams. You can, of course, work time-wise supporting this team and then go back to your research question. So it really should be teamwork in this group. And then after this workshop today, you prepare your research question. You make your decision, okay, this is the research question I'd like to choose. You take Danilo's template, prepare a first draft, brief introduction, hypothesis, and methodology you'd like to apply, perhaps first definitions, and you prepare this for tomorrow for the academic session. And there we'll get feedback and discuss so that we simply running all in the same direction or can add ideas and get feedback, of course, from Gitcoin and Block.Science. All right, any questions on that? No? Okay, then let's start, Marc. Stage is yours. Introduction to the Gitcoin Grant cadCAD model. Please share your screen.
I share my entire screen, yeah?
Your entire screen and whatever you'd like to share in addition. Yeah, there we go. We can see it.
Okay. I prepared a bit of a structure for myself to have it on a Notion page. So basically what I would like to do is getting started. How do you get started with cadCAD? Because this is about the cadCAD model. Of course, the Gitcoin project has provided us, or maybe the token engineering project, I don't know, or Danilo has provided us with a GitHub thing. So if you want to get started, just begin by forking that Gitcoin cadCAD model. because we need to get our hands dirty anyways. So might as well fork it, and maybe you have something good out of it, and then you can do a pull request on Danilo's repo, and maybe you will succeed. So basically, this is some nice perk you can earn after this course, maybe. So basically, fork the Gitcoin cadCAD model, build some branches on it, and get on with it. So the thing I noticed is that first of all, you don't have any data to run your model on. So you need to get the run simulation.py file started. And I also noticed, I did this this afternoon, if you and it's really written very well in the files themselves. So it's a well documented repo. Thank you, Danilo. You could do two things. You can run a simulation with a number of time steps all. That took me a really long time. I'm only on a CPU, but I aborted that and I tried it with 6,000 time steps. Basically the ones that was shown in the example of the repo. And that took me about a couple of minutes, 5 or something, on my MacBook. So be sure to be wary of the number of time steps you want to include in your simulation. Basically, what this is doing is getting the raw data, the contribution data of the round 7, I guess, Gitcoin Grants into your system. And then the fun begins, because then you can open your notebooks. First started with the Dynamic Network notebook, and later on with the Graph Communities notebook. Yeah, before we take a look on that thing, first back to the cadCAD structure, because well, of course, lots of you already took the course, I presume. If you haven't done that, I really can prefer that you will do that, because it gives you a nice overview about what cadCAD is about, and it has a low threshold of onboarding you onto cadCAD. Since we are working a lot with cadCAD in this course, I guess this is a no-brainer. But if you really want to, TLDR kind of stuff, I put together here some basics. And actually, it's written very well in the dynamic network.ipynb, the notebook file. It's all there, but just to summarize for you, what I always do if I run a cadCAD model or if I'm building or updating a cadCAD model, I first look at the state_variables.py file, because this is basically the root of your model. This is where your variables in your simulation is going to be updated. Or basically, this is the structure of your simulation, I would say. And so you have to take a look there. And actually, it's a very small file. We can take a look at that just a while. The next important file, I would say, is the partial state update block. This is basically the dynamics of the simulation. Here you state what you want to achieve during the simulation and in what order this would be. And of course, how you do that, or this is basically in the partial state update block, you state what you are doing. And in the functions that are mentioned there is, of course, the implementation of what you're doing, the how. And this is basically put in the system.py file. What I would say is a bit too cluttered for my, in my opinion. I would flesh that out into separate files, each one of them basically a building block for the partial state update block. But well, you can discuss about that. So what about this dynamics? If you can see, there's some sort of a convention taking place there. And that's a really nice convention because it's obvious, it's instantly clear what those functions intend to do. If you look at the P_type functions, these are your policies. If you understand a bit about cadCAD, it's all about policies and mechanics. And policies are basically what you want to achieve. And the mechanics are basically your state update functions. So in the policy, you determine what you want to achieve. In the state update, you actually execute that part and update the state accordingly. So P-type function are policies, S-type function are the actual state update function in order to get your simulation moving forward and updating the state. Well, this is an example, of course, of the partial state update block. I think it's from the dynamic network thing. And what you can see here is, well, it's neatly labeled append new edges to the network. So basically, this is what you want to achieve. And this is what kind of state variable is going to be updated after you execute this policy. And it's quite clear you have to append a contribution. The other things are more like a what I would say a statistics-like simulation round. Here you do the actual quadratic match, and that's being split into two blocks. One, what I would say the full Monty of quadratic funding, together with pairwise comparison, an algorithm I try to get a grasp on, but I find it quite difficult to understand. But there are lots of knowledgeable types here in the call that can educate me on that stuff. And you have a block simple quadratic function that is without the pairwise. So here, basically in the simple quadratic function, you could see that the actual what the quadratic funding algorithm is about. So that's the, let's say, the algorithm without the bells and whistles, I would say. If you dig into one, you see these are quite simple functions. What you do in, for instance, here in the new contribution policy, what you are saying is, okay, what time step am I in? And I want to add a new contribution. I get it from the contribution sequence parameter in that time step, and I add it to a new contribution variable. This one is fed into the state update function as append contribution. You have to deep copy the previous state. I had some difficulties when you have large objects hanging around. Basically, the cadCAD model is about more like a functional programming style, I presume. But then again, I'm not a Pythonista, so this is just my imagination, maybe. And here you append the new contribution from the policy input you get here into the state here. So here, basically, this is the state update function for the contributions. All right, so this is a bit of a theory about how I would like to see how a cadCAD model is structured. Basically, it's basically around these three files you need to address your updating or your if you want to hack on that. And let's take a look now at the actual stuff. This is the dynamic network notebook. And what you can see, this is a really nice overview of how this notebook is structured. Also a really nice overview about cadCAD, how that is structured. You can see here the files are mentioned. So it's really worthwhile to really read the notebook beforehand. Before you go start hacking around. So these are all the cells. I would like to have a short overview of what is actually after the simulation, because I already ran a simulation. This is something which might be confusing, because cadCAD is built around you do simulate, you add a state accordingly, and basically you fill your data set during a cadCAD model simulation. But I already did that beforehand by using that run simulation.py file, and this is basically the result result I take in order to get some statistic around. The dynamic network file, the dynamic network notebook, is actually a statistics file. You get all sorts of plots about statistics around this, all this contribution. Like for instance, something is not here. You can see you have an overview of the quadratic total funding during those time steps, and you can see it's growing well, mostly linearly with time steps. So basically, this is the funding that is built up during the events of the round. So actually, what I would like, this is taking maybe too much time, but just play around with it, add some cells. Maybe if we go to the graph communities, which is, I think, slightly more interesting notebook. There you can see something of, this is called a cluster. I won't say a cluster fuck, but it's a cluster plot. In any way, it's quite complex to me. This is slightly better. Don't know what this means, but certainly I will be educated about that. What I really like is this one. Where do I have that? There was some plot community, I think. Well, I can't figure it out yet, but there is of course a bipartite graph somewhere, or is this in the other one? Maybe it's in the other one. Let's see. Sorry. Yeah, here. This is this one. This is a real nice overview about what kind of contributions are being put into one what kind of grants. So this is a bipartite graph of the 1,000 time step. Well, actually it's not. It's about the 2,000 time step. You can play around with that by, just putting here 1,000. And then you get at that simulation point the contributions at that time step, at the 1,000th event, actually. So if you put here 0 to 1, hope it still runs. No. Maybe 10 to 11. And you see, this is the first 10 time step. Of course, not a lot happening. But this is basically what you can see. You have a contributor, one contributor, and he's already staking at several grants, you can see there. So you have only 2 contributors staking to several grants. So this is interesting from a research kind of perspective. What is happening during the rounds? Are contributions being put actually in the beginning of the round or more at the end of the round? And what kind of contributors are staking early on, and what kinds are doing that later on? I think I took up too much time already, Angela. I will stop here.
Okay. Hey, thank you so much, Mark, for this overview. Cool. Who had the chance to cadCAD. I guess most of you haven't used cadCAD beforehand.
I have a question.
Mm-hmm.
So I started the online course for cadCAD, and Mark, you mentioned forking the cadCAD repo. Does that work together with what I'm learning in the course? Because I'm kind of new to Python and I'm using Anaconda. Is that work together with that, or would that be outside of Anaconda?
Yeah, you have a steep learning curve ahead of you.
I'm used to steep learning curves. That's okay. I'm good with that.
It should work, but we have a real expert here in the room. Sean, can you help us out here?
Maybe we can do that offline if someone wanted to.
Yeah. Is it Jay or what's your?
Jay. But we can do it offline. I can do it offline.
Jay, just shoot me a message anytime. It will work. I mean, there's many ways to skin a cat, as they say. So you will get it working, but you're gonna have to play around with it, and just don't be afraid to reach out to really anyone on the call here. And we can drop into these voice chats anytime as well if you just need to screen share something. So
thank you.
I
had another quick. Thank you. I appreciate that. I have another quick question, Mark. You mentioned a certain kind of plot. Was that cluster _fuck or just cluster?
No, it's some sort of cluster plot. I can't understand what I'm looking at actually. So this is basically what I make of it, a clusterfuck for me.
I was just joking.
In my perspective, this looks like a clusterfuck.
So Nilo, can you shed some light on this graph, because I had some of similar experience.
Yeah, actually that because let's say those notebooks were sort of exploratory data analysis. So when we did that cluster map, we were sort of wanting to gain an intuition how the pairwise matching would look. In the sense that, let's say, this sort of gets the correlation between contributions. But I mean, actually, it doesn't mean a lot of things. It was just an exploratory thing that we were curious to see how it was. But there is no meaning to it.
These kind of charts that always look really fascinating in a blog article, but actually don't mean anything.
Yeah, I mean, they do actually mean something, but I mean, the interpretation is a bit complicated and we didn't get any insight from it, so it's better to interpret that there is no meaning. But actually, if you dig in deep, there is actually a meaning.
Yeah, sure.
But it didn't give us any insight, so it is useless.
Which brings me to pairwise funding. Jaja in the kickoff video snippet mentioned this briefly, but we haven't had a good definition of it. Can you give us a brief, what is pairwise funding or this algorithm?
So let me think how I can put that. I think that, let's say, the main idea of the pairwise term thing is about removing the correlation between the contributions of users. In the sense that, let's say, you have lots of people that donate to the same grants. And the idea of the pairwise match is to, let's say, to penalize the people that always donate to the same grants. So, I mean, if you have 10 friends that always donate to the same grants, to grant 1, grant 2, they always donate to the same, the pairwise term would penalize that. So, in a certain sense, the pairwise term rewards, let's say, rewards things that are not correlated. So, I mean, if you donate to several grants, but your pattern in regard to the donation is different from everyone else, you are going to be rewarded. The way that this is done is through... I mean, there is the mathematical specification where that is put clearly, but I would say that the main fact is that pairwise term penalizes correlation between the pattern of users.
So this seems to try to reduce this. Okay, the big grants are becoming bigger and bigger, and everybody is betting on the same horse in a way.
I would say that, let's say, the idea behind of why Gitcoin adopted it on first place is that there was idea that this would reduce collusion, this would reduce the total match that colluders could take, but this is entirely hypothetical. There is no relation whatsoever with penalizing large grants or not. But of course, it could be. Actually, there is not a lot of empirical research about the effect of that term. So, I mean, we don't know a lot about how it affects the system. And actually, one of the reasons of why you see on the cadCAD model a policy for the simple quadratic match and the full quadratic match is that we were interested on how they compare themselves, because right now we don't know, we don't have a lot of empirical results for it. We have that dynamical network notebook that, let's say, gives us some statistics, and I mean, that could be a starting point, but right now we don't know a lot about what the pairwise term actually does to the contributions. I mean,
I see.
we have some hypotheses. There is some ideas of why what that will do, but it isn't validated experimentally.
And it is implemented and rolled out or not in the actual running system in production?
Yeah, it's implemented, I think, since around 6 or 5.
Could I ask a question, Danilo?
Yeah?
So on the pairwise thing, I'm trying to grasp it. Would it be accurate to say that if two people tend to behave very similarly, it reduces their contribution by treating them more like one person?
I wouldn't say that. I mean, I didn't explore fully, let's say, the analytical implications of that. But what I can say is that, let's say, if you have two persons that behaves exactly the same, they are going to be penalized. But I didn't take the time to let's say, to know how much. Let's say I don't know what's the rate of the convergence. So it's a bit of stretch to me to say two people are going to become one.
But so it's intended to reduce the impact so that two people shouldn't have double weight if they're consistently doing this. Is that accurate?
Yeah, let's say the idea is to reduce their weight. If people behave the same, they should have less weight. But let's say the amount which this weight is exactly reduced, I didn't explore that. So, I mean, I don't know what is the exact equivalence.
Thank you.
You're welcome.
And on a side note, Gitcoin Grants has two elements in the interface that might cause a bias towards a similar behavior. A is the card checkout and the option to share your card once you have contributed. And since it's a lot of clicks, just imagine you have more than one grant you'd like to support. If you do it, you start from scratch, you have a lot of clicks and then collect your card and then check out. While if you build on a card that's already there from your friend, somebody you like, or where you think, okay, this person really has expertise, I'd like to donate to the same grants, then you would just use this link. And the second is collections that are also collections. We had, for example, a token engineering collection where we presented token engineering grants worth supporting. Then, of course, this could also lead to a similar contribution behavior.
Yeah, and actually one of the main first conclusions that Jaja had is that the pairwise term penalizes the idea of having collections of grants. So I mean, this is actually, let's say, a hypothesis. I mean, it's not a conclusion in an empirical sense. It's a conclusion, let's say, by reading through the algorithm and thinking about what would be the implications. But I mean, we don't have, let's say, a hard number for how much. And actually, I mean, this could be a super interesting research direction. You could, for example, maybe select a given collection of grants, or maybe all collections, and try to simulate what's the impact of the pairwise term on the match for those collections. So on our cadCAD model, we have, let's say, the match for the simple quadratic funding and for the full one. And the idea would be you select all the grants that belong to a certain collection, and what is their total match without the pairwise and with the pairwise. We don't know what this number is, but I mean, if we get that number, we could have a hard estimate of how much this is impacting. Maybe does it have impact? Maybe it's 5%, maybe it's 20%, maybe it's 100%. We don't know.
Yeah, cool. Any other comments or questions on Marc's presentation on the cadCAD model? No, not yet.
It was a great presentation,
So
by the
again,
way.
yeah.
Thanks.
So I have another question. You mentioned doing forks and pull requests.
Yeah, plot. Yeah, right. What is the question?
Yeah, I'm curious about how not the mechanics of how the pull request process works, but when something is like what's the criterion for something being good enough to submit as a pull request, I guess.
Basically, that's the on the receiving end of the pull request, and basically that's Danilo. He's in charge of selecting the best propositions, maybe. Well, no, there's not a real. I think if it's good enough or not, it has to add something to the current model, something that hasn't been tried before, or maybe even a bug that you discovered could also be a pull. You could also open a pull request for that. It's just the community way of making something better, I would say.
So to describe a bit, because as Mark said, there is, let's say, there is the sender side and there is the receiver side. So in order to submit a pull request, I mean, there is no criteria at all, because you can always send a pull request. But on the receiver side, which is, let's say, what is needed to accept a pull request, first thing is that, let's say, there is a difference between a pull request to the master branch and towards another branch. All pull requests that are going to a separate branch besides the master is going to be accepted, even, I mean, independent of the quality. So if you create a separate branch and you want to be included on the Gitcoin repo, it's going to be accepted. As for being accepted on the master branch, it depends a bit. So for example, if you modify an existing file or maybe modify the existing model, then it's going to be passed through a review process. So I'm going to review it manually, see if it doesn't break anything. And I mean, the main criteria is it must not break anything. If you add something, even if it's not, let's say, top tier quality, if it just adds and, let's say, doesn't generate any side effect, it's going to be accepted. Another thing is, let's say, if it doesn't break, but you are simply adding a new file, maybe adding a new folder, maybe creating new notebooks, most probably is going to be accepted. My recommendation is, I think that we could create maybe a folder called notebooks or maybe a folder called research. But anyway, if you guys structure, let's say, anything that you build in such a way that doesn't break and, let's say, doesn't make a lot of pollution on the repository, most probably is going to be accepted. I mean, if there is any doubt, maybe the best strategy would be to simply send a pull request to a separate branch, and then afterwards we can discuss merge strategies in case of you are in doubt. But I think that, let's say, the main point on the receiving end is, let's say, it must not break existing things and it must not pollute the user experience. So that's it.
Thank you.
Okay, anything else? Otherwise, let's move on with Jan's presentation. Oh yeah, and final remark, if you experience any challenges with setting up your Python environment, your cadCAD, just drop messages into the Discord. And again, we all had this learning curve and we are happy to help. Good. Jan, are you ready?
Yes.
Okay.
Share the right screen. It work?
Yes, it works.
I think
It's good.
Okay.
Hmm?
Can you see it?
We can see it.
Okay. So you can basically see the presentation, right? Okay, perfect. So like I basically just made a short presentation on the Gitcoin Grants data. So I split it into two parts. The first thing is overview of the round 7 and round 8. And that's gonna repeat some of the things that basically Kevin presented already. And then it's just gonna be like some basic stats on the how rounds evolved over time. And then I will also dive into the sample data that's basically in the GitHub repo. So for the round 7, so basically like every round kind of like increased the contribution amount, and also most of it also the matching pool. And here you can see basically that it increased from round 6, it increased 150%. And then also there were a lot of new projects and also the new category structure. So that's more on the product side. So that's why there is the product side and the research side, and I will go quickly to the product topics. So when it comes to the product topic, this is like one, for example, that in the round 7, the increase was driven by DeFi projects, which basically were building their reputation somehow, because in some ways they might not have been totally accepted by the whole Ethereum community and so on. And also there's another interesting thing, which is the collection feature, which is something that was mentioned before, and I think in some way also basically impact the data that we're looking at. But I will basically pick that up later. So around 8, we can see that it increased the amounts from 275 contributions to 571, and then the matching pool increased, and also the contributions based the projects basically increased. And then the insight, this is mostly again product stuff. So for example, in the analysis by either Vitalik or the Gitcoin team, for example, they mentioned a couple of topics that they were looking into. For example, the pro quo is, for example, one where the teams were giving out certain rewards for the people that contributed to the Gitcoin grants, or for example, the determination whether something is a public good or not. But those are all things that are somewhat independent from our research questions, right? So the biggest thing I guess for us is either the Sybil attacks or the collusion attacks, and here it's also mentioned that it was implemented the pairwise bonding matching algorithm, which is again the correlation thing that we mentioned before. And then the trust bonus participation, which is based on whether somebody was approved through their email or some other providers. Basically, they got a higher weight in terms of their relative to others. And then also the discoverability, which is again something that like they were doing some A/B tests. And this is the rounds amounts over time, the statistics behind it. and we can see that it's growing quite well over time. I will not go deeper into this. And then also the insight in terms of the cohort analysis over time into not sure how familiar you are with this analysis, but you can see that, let's say, over time, about 20 to 30% of contributors also contribute in the next round and so forth, right? So, for example, let's say this is basically this is round 3. It's all contributors that started in the round 3 contributed in round 3. Then we can see 44% of the users that contributed in round 3 also contributed in round 4, and that basically like usually goes down, right? That's kind of like the analysis that is done in all product businesses, right? And this is just like a good metric to get into, but again, it's independent from our research. And then I have the Google Colab, the analysis on the partial data of round 8. So this is something that I can share later, and also the presentation, because it's essentially just like I just went through all the articles, the blog posts that were written, and I just put together some information on that. So the first thing that I did, I just took the data from the GitHub repo and just got it into a nice data frame. And something that I noticed right away is that like in quite a few contributions, the amounts are replicated across the same contributor. And that's also something that like I noticed that the same amount across multiple grants in the same contributor might actually mean that this is basically a collection, right? Like we don't know that, but that's something that, let's say, it might mean that people can put money in the same collection, and that might be interpreted as the same, let's say, copying or collusion and so on, which is obviously a false positive in this case. And then if you go further, this is basically just the basic stats, and we can see that we have 17K time steps. And then the interesting part, of course, is the amount. Because the flag, I think it doesn't have any signal, because you can see that all of the values are 0, because the max is 0 and everything 0. So the amount is the interesting part, right? So we can see that the mean is 23 and the median is 2.7, which basically means that it's quite skewed. We can see that also from the standard deviation. And then also that only 25% of individual grants are basically above $5, right? This is basically the 75th percentile. And then when it comes to the contributions, the contribution amount, the total is 407K. And here I basically made a comment comparing that to what was reported in the round overview. And this is, of course, because we have partial data. So we cannot expect all of those. And then also the unique contributors is lower, 4.7K compared to 5,000, which was mentioned in the round overview. And then also the number of unique grants is lower. And because like I basically saw here that so the grants are very low, let's say lower than $10, and that's something that I basically also calculated here, is comparing to all of the grants. So this is basically just limiting only the grants that were below $100, because if I go further, then it's totally skewed and it doesn't give me any signal, right? But here we can see that more than like almost 90% of grants, the grant contributions are lower than $10. And then I basically just split the contribution amount, basically the top contributors by total contribution amount, and we can see that we have like two kind of whales, right? That have contributed, let's say, 100,000, and the other one, let's say, 70,000. So that's 170,000, which is, let's say, not half of the total amount that we have in the data set, but close to that, right? So also this is highly skewed. And then the number of grants per contributor, we can see that it's highly skewed. So that's why I basically just took the contributors that basically contributed from 1 to 10 grants, and we can see that again the number 1 is the most prevalent, and that's basically 3.2K, which is compared to the 4,721, it's 71. So let's say 71% of users contributed to 1 grant, and then we see like a huge drop after, right? So that's like another signal that we get, that it's not like a normal distribution, not at all. It's like as usual in social systems. So then top grants by total contribution amount, we can see that like again we have not outliers, but like 2 projects that got like a huge amount, right? But on the other hand, if we check the top grants by unique contributors, we have a very different picture, right? For example, Bankless, that got the most unique contributions. It's not here, but like it's not in contribution amount, right? And that's something that I will also like check in a Sky report. And then just plotting the top grants, so that top 10 grants, and then I basically just checked whether people that contributed to these grants basically contributed to very similar grants, right? So it's somewhat like pairwise correlation, but a bit different. Like it's simpler. Also here, like I'm basically just filtering. For example, here, like I'm just taking the top 10 grants, right? First I sum up. First I group by grant, then I sum it up, and then I take the amount, and then I sort the values based on the total amount, and I take the top 10, right? And then I get the names, which is basically this, right? And this data frame is basically this thing that I'm showing here. And then I also filter the initial data frame, which is all the grant data, with only the grants that are in the top 10, right? So that's why, like, I do this because I want to show like a reasonable amount of grants in one visualization. And here you can imagine if I show this 500 grants or whatever, there won't be much signal. So, but here, like, we can already see certain patterns, right? For example, here we can see that the EU crypto initiative, it's not very correlated or even negatively correlated with others, but some other, it's like, for example, the Gitcoin open source support fund, it's quite highly correlated, or this one, the Fiona Kobayashi software engineer. That doesn't, of course, mean that it's collusion or whatever. It's especially because I filter only the top. Like, if you compare this to the whole, to all the grants, that this correlation will obviously go down. But it's just like a nice way to visualize. And yeah, we could basically do some more sophisticated analysis on top of this. But the basic idea is this, yeah, that, like, for example, like the more the amounts are contributors to which grants they contribute their amounts to are correlated, the more red it is, and basically, like, the more white is basically neutral, and then blue is gray is negative correlation. And then I basically just inversing. So here it's the top grants, and then I checked at the top contributors. So this is basically the same contributors that were mentioned before. So basically these two whales, the almost 100,000 and 70,000. And here we can see, for example, that how this is correlated. For example, we can see that these two, the 491 and the 0C0 is highly correlated, like much more than everything else. But a lot of them are just not correlated at all, which makes sense. if I basically look at this individually, I can see that the one which is the top one, which is 491, this one is 0C. I can see that all of these, this one has more grants like that they invested in, but this one is we can see that there is a overlap between, let's say, the Ether.js is here, then the hard hats deploy. Like basically all three of them are also in this grants, right? So that basically indicates that there is definitely like some overlap, and that's also indicated in the visualization itself. So that's
Maybe
this, and then
we can. Oh, if we have some questions so far, since this is rich in content, and just in case.
yes, please.
Any questions on the analysis?
Just one question. Is there any correlation between recurring funding and one-time funding? Because I think Gitcoin has an option, right? That as a project you can have a recurring funding or one lump sum funding.
So in this data, we cannot get that because it's basically just grant route 8, right? So this is not the kind of insight that I would be able to derive from this data. This is just one round and like a sample from that round.
Okay. So was it round just for the lump sum thing or also for the recurring round?
It's not for recurring round. As far as I know, this is the only data that is available. Especially, I mean, like in the GitHub repo for sure. That's the only data that we have available at the moment.
Okay.
And anyone, if that's not correct, just please correct me.
I mean, I know that there is the option once you contribute, you can define if this should be a recurring contribution or just a single time contribution, but it seems that this flag is not included in the data set.
Yeah, I think so, yeah.
I wasn't really sure what the flag meant. Like I basically just saw that all the values are 0, so I assume that it's not worth exploring into, and that's it.
Yeah.
So and the last thing that I looked at is the total contribution amount versus uni grant contributions, which is, let's say, the intuition is that the more unique contributors, the more total contribution amount. That's, yeah, sometimes it's not the case. And then if we look at the visualization, this is the number of unique contributors in the project. This is the total contribution amount. Then we can see, let's say, that there are certain outliers, like here, Bankless, that you mentioned before, that doesn't have, let's say, a huge contribution amount, but has a lot of unique contributors. And then on the other hand, we have these two outliers, which are the hard hat and the coin center, which are basically like don't have that many unique contributors relative to their total contribution amount. And this is maybe more penalized, let's say, based on the quadratic funding mechanism, right? And this one, for example, like I imagine, like I don't know, like how much match funds they got, but like I imagine that this got quite a lot, considering there were a lot of unique contributors. And then, yeah, the last thing is just checking the top grants by average contribution per contributor. And this is, yeah, most of them are basically here because it's, let's say, like 1 or 2 contributors and then like a huge contribution amount. So this is, again, it's the 3,000 is not very representative, but it's basically just checking, yeah, just certain data points and just seeing whether there's some signal here. I think that's it when it comes to the whole analysis. Are there any questions? For the analysis itself, I can basically just share this presentation, and then you also have this Colab notebook here. then you can just play yourself, or just copy the notebook and then just do whatever you want with it. Because like I think it's a nice way to explore the data set. Yeah.
Cool. Thank you so much for sharing. I think it's really worth having a look at the notebooks and play around with it in order to get some first indications or proven assumptions. Any comments or questions so far on this analysis? Overwhelmed by content.
Like maybe I just share too much. Not in a good way.
I have a question. I have a
Hey,
question.
go ahead.
Two, actually. Where you said the data was on the cadCAD repo. Where did it come from originally? From the API? And then the second question is there data that you felt you were missing as you were doing your analysis that you wish you had?
Probably like I am the right person for the second question, not for the first one, because I don't know about that. But the second question, like one thing that would be useful is, for example, for the collections and maybe just some product related things. I'd say like also like some metadata on, let's say the time steps. This is also something that is quite unclear to me. Like how, let's say you have the same amount, which would mean that somebody made something in the, like as a user collection, but at the same time, then it would need to be the same time step, right? I mean, considering that they clicked on it at the same time. But then that could be then induced that basically it's somebody used a collection. That's not the case, because it just like the time step just looks like just number of rows, and so it's not very informative in terms of also how this evolves over time. It's just like just arbitrary, just using the rows and that's it, right? So this would be another thing that would be useful, like actual timestamps. But maybe that's just not good for that you can basically recognize who made the contributions and so on, right? But that would be useful, yeah. The time dynamic, yeah.
And I don't think you had the actual matching amount that was given to each grant after the fact either.
No, just the contributions, the crowdfunding amount.
Thanks.
Okay, once again, the matching amount then is only summed up to a grant and matched to a grant overall, and not to an individual contribution. This is not available. How an individual, so the matching on every individual contribution. We don't have that.
Yeah, like the data itself is only the contributions of like the donations from the individuals, right? So and the matched amount, that's something that is just done by the cadCAD model. Like the way I understand it.
By the
Yeah,
way,
but do we have?
I would even say that, let's say, an open research problem that exists is exactly about building, let's say, expression about how much the contribution represents in terms of match.
And at the moment, in the data frame, we only have the total matching.
We can have the match per grant, because let's say the way that the algorithm is built up, we calculate the match for each grant. We don't have let's say a match for the contribution. That would be need to be developed.
And regarding timestamps, I mean, at the moment, the model is producing one contribution is equals one time step. But then if this was due to a card checkout or a sequence of checkout, this is not defined or not visible in the data frame?
We do have the informations for the timestamps, but on the simulation we use the contribution sequence. So the timestamp is the order, captures the order of the contributions.
And then how does, if you check out a card, so you check out 10 grants at once, this is then via the transactions on the blockchain, or how do you order?
That's a good question, actually. I have the feeling that is about the blockchain order, but I think this should be a thing that I mean, I think that we should make clear that.
And Danilo, what was the original source of the data? Or how was it obtained?
So the data comes from an internal database from Gitcoin. They do have a metabase, and that data set that is on the repository is sort of a cleaned version of it, because I mean, there is a lot of sensitive data there, because when you look at the hand data, you can actually see people's wallets and so on. So we need to keep that out, and also remove. I mean, only provide the information that is needed. Because having timestamps, I mean, if you know where to look on blockchain, you could trace also the wallet. So we need to take care with those things.
Okay, anything else? Not at the moment, I guess. You can at any time reach out to Jan in case you have questions and play around with the notebook as well. Thank you again, Jan, for sharing this. Great work. And now I think it's time to work on our research questions. So first, before we start, I'd like you to check out if you can use Lucidchart. You might be aware of that tool if you've taken this bootcamp, the cadCAD bootcamp. There are some templates available for plotting and mapping out system diagrams, and I think it makes sense to use and try out this tool in any case, since it's quite useful for all kinds of visualizations. And I'd say you have 5 minutes to go to Lucidchart. Let me share the link. I prepared a board where we can share our notes from today's session, and I will put that into our Discord chat, so the TE Gitcoin Discord. And then please go to Lucidchart. And yeah, there are free accounts. Should be quite easy to create one. And then we will meet there in 3 minutes, I think. I'll share this already. Okay, so I see some of you are already on the board. Let me know if you have any issues in accessing it. Jan, Darian, Matt's there. Okay. Are you ready to go? Okay, we are still missing some of you, so make sure to go to the link I've posted in the Discord, in our chat.
Yeah, I'm trying a different browser really quick. For some reason, it's getting that there's an error.
Okay. I'm using Firefox at the moment. Works fine. Okay. We slowly start, and there's some time left to be on the board. What I want to collect now in the first round is brainstorm the most exciting research questions throughout this presentations today, the sessions we've had. And it doesn't matter if you feel comfortable with working on this research question yourself or alone. It's just some of the aspects you really think are worth exploring and that we should take a look at in this research group. And just pick a note, a post-it, and one post-it per research question. Just take one and put it to the right on it. First, everyone is removing it from the board, but finally, your research question should be back on the blue board. And let's collect the most exciting research questions, most valuable research questions you see in this project on this blue board. I'd say 5 minutes, type down and create as many posts as you can. Just don't think at the moment it's not on defining the method, how to explore that and how to verify that. It's just type down most exciting research question from your point of view. 5 minutes.
Is the app freezing for anybody else, or is it just me?
Again, please. What's the problem?
I'm seeing if the app is freezing for anybody else, or is it just me?
Aha, no. Looks fine on my end. Okay, 1 minute left. You might want to complete the question and then make sure that your post-it, your note is on the blue board. Most exciting research question. Okay, maybe you can also remove all the notes we don't need to use at the moment, or there's no text on it, and then okay, then let's take a look at it and see what you think is worth exploring in this research group. Now, I think we can all look at one screen, so I'll try to share, but feel free to add notes while we are discussing. And let's start with, can we build a model of known methods of collusion and fraud to see how to subvert this? Who has put this note? Who has added this question? Who was it? Can we build a model of known methods of collusion and fraud to see how it works?
Hello? So I'm not sure. There we go, so I can. Yeah, it was me.
It was you. Okay. Can you say some words about this?
So when I was sorry, just turn on my light. When I was reading about the kind of why token engineering, it came up a lot of previous attacks and kind of ways things were exploited. So I was just wondering, having all that knowledge, is there possibility for us to kind of build out these strategies so then we can, I guess, build like models and detect them in the early stages?
Mm-hmm. So this would require, if I understand it correctly, this would require that we have a good picture of existing collusion, right? Of actual collusion taking place.
Yeah.
Okay. Maybe then also a challenge to, I mean, there you have to reveal I am colluding, and it looks like that.
Yeah, exactly. Yeah. That was what my kind of interest was. It was to kind of fabricate that type of collusion and see what that looks like in terms of a model, and then kind of figure out if we're seeing that anywhere else or.
Mm-hmm.
So I have one that might be kind of related, just directly to the right, skipping over the big one in the middle. Can we use reinforcement learning in our simulations to identify collusion patterns? I think we might be able to use AI to identify collusion patterns. This is common in like in AI research. There's often video games are used as the research bed, and sometimes brand new sort of exploits in these video games are discovered by the AI systems. So I wonder if we could get the objective function right, sort of have this like collusion objective function, kind of like the optimality gap that we see in the research so far, and have some AI systems that can find these collusion strategies, and then we could like index them to build a model of known methods. That'd be pretty interesting.
Cool. I've put the note next to who was it? Darian? Who was it who was proposing can we build a model? Not sure.
The question was my question, and then I think YGG was similar.
Yeah.
So.
Okay, cool. Sean, do you want to? Do you have any other posts to go next with your posts and suggestions?
Sure. I have about 3 ideas that I kind of rambled on in various sticky notes. So there's like 2 columns where that AI one come from. There's I think 7 more. So one of the main ones I'm interested in is like, can we collect additional data sets? So for example, for each grant that was rewarded, maybe we could even manually, we could just find like a website for each grant. I don't know, that might be a lot depending on the grants. Maybe we could do that automatically. But then I was thinking if we could connect to, say, Twitter data, if these grants are associated with some sort of Twitter account or GitHub. It's in the top right there, the metadata. Can we scrape project metadata? Yeah. So yeah, I think that'd be interesting too. And then I kind of go on. I think the most interesting one for me is Twitter. It'd be interesting to sort of model Twitter networks and then compare that, if we could do some sort of comparison analysis between Twitter networks and the Gitcoin grant networks, or any sort of direction that this sort of metadata approach could go. And then the other main topic I was thinking of is like optimizing, just general optimization of the Gitcoin grant system. So I was thinking like what kind of measurements, and I think this one's the most abstract, but like it's just down below, how can we measure optimal funding for the ecosystem, such as maximizing impact, innovation, or well-being? And then below that, what other metrics can we use to measure the health of the ecosystem? And I would like to just read sort of the mission statement of Gitcoin and see really what are they trying to do? What are they trying to maximize? I think it's funding for public goods, something along those lines, but I haven't read their sort of mission statement. So it'd be interesting to see what they are exactly trying to achieve. And if there's any sort of like branches we could go off of this for optimizing different impact measurements. And then, so those are the 3 ideas, I think. I was like, can we use AI? Can we sort of scrape additional metadata? And what other metrics can we research for the ecosystem? And if you can just, the 2 sticky notes to the right, those ones are related. And the one at the top left there.
Okay.
Oh, yeah. The one in the top left, this is about matrix representations with the research that Danilo has been doing. Basically, just any network data structures that we're using. I know it would be cool, we've talked about this a few times, to translate the network algorithms to like vector and matrix representations for computational efficiency. So I find that one quite interesting too.
Okay, cool. You can choose who should go next.
Okay, I'll pass it over to Nico.
Hi, how's it going? Cool. So I've got 2 that I was kind of looking at. So I was interested when I heard about how one of your guys' major priority is Sybil attack, and I was reading about how you're planning to use like Bright ID and all these things, but it's still such a high priority. So that makes me wonder why. So that's one of my questions. My second question is something I've been kind of wondering about, though. There's so a lot to think about, but maybe using like quadratic funding for rewarding data stakers. So yeah. Yeah.
What do you mean by quadratic funding rewarding data stakers? Maybe I got this.
So if you have like a pool of rewards that you would like to use in Ocean Protocol, and people are staking in data because it's good data, then you can kind of match like what people are doing and kind of like reward those stakers in its appropriate way, and that's the way to funds.
So to apply quadratic funding to a different use case and project and network.
Yeah.
Right? Yeah. Okay, makes sense. All right, good. I wasn't able to find your sticky notes quickly enough. Maybe you want to put it in green or another color, and cluster it if you want to, if you have several on the same topic.
Sure.
Okay, Nico, who should go next? And all the others, please ask if you have any questions on the proposals and on the questions.
So I guess I'll choose Mark.
Okay. So I moved the emergence of subgraph behavior over time to the left. I'm really interested in the dynamic behavior during a round. So what do I mean by that is that if you can see how contributors are staking on grants over time, maybe you can discover some sort of behavior, collusion-wide or not, in order to get some meaning about what is happening over time. It's a bit about the dynamics of the simulation I would be interested in. So what kind of subgraphs are emerging over time?
Okay. Anything
I have
else?
some other sticky notes over to the right in green.
Okay, can you move them over to the left board?
Yeah, but okay, yeah, sure. Yeah, these are not my most exciting ones, I would say.
Yeah. Just go for it.
Okay. So the other one is more data from other rounds, because if you have more data, maybe you can see some sort of behavior emerging over time as well, and do some Monte Carlo runs over it. That's a neat cadCAD feature I haven't tried before, so that's only my personal interest in playing around with that. Also, as we said, as we looked at the model, basically it's about past events. What I would really like to see if we can move some sort of randomized contribution simulation model or something like that, and do a test. Well, maybe it's something that is similar to what Sean is trying to accomplish with his reinforcement learning agents. Put some AI in the mix, I would say. And then, the weights of contributors as input for subgraphs. As I said, there were really nice graphing techniques being pushed in in one of the notebooks. But they are all, the circles are the radius of the circle is proportional to the amount being staked. What is really nice to see if we can put, instead of the radius, put weights on the edges, so you can see what kind of contributors are going to stake with what kind of weight on what kind of proposal. So the weights as an input. Maybe you can look into that kind of stuff using some sort of networking algorithm to see what's happening over there. Maybe it has something to do about the emergence of subgraph behavior. So I would say it's aligned to this one. And then last but not least, get a chaos monkey in the simulation. What do I mean by that? Netflix has some sort of algorithm. They call it the chaos monkey, and this one is randomly putting out services, or just pushing buttons all the time randomly. So maybe if we can simulate some kind of a let's say an adversary or somebody who looks like he's behaving correctly, but instead he's behaving badly during the round. Well, just a while here. Don't know if that makes sense.
Okay, yeah, interesting. Chaos monkey. Any questions, everyone? Okay, otherwise, Mark, who should go next?
Octopus.
I tried for 10 minutes on 2 devices and was unable to add a note, so I apologize for my tech incompetence.
Do you have any notes? Then I'll write it down for you.
Yes, I would. I guess I'm interested in investigating. There's this notion in the optimality gap of an optimal subgraph, and one thing I'd be interested in doing is investigating that question from a theoretical perspective. I'm a pure mathematician, so simulation is not my first tool. So I'm open to doing simulations and contributing to those, but all of the questions I'd be interested in bringing some other, maybe a different to them. And if there's not a lot of interest in determining the optimal subgraph kind of more directly, I'm pretty much open to working on anything.
I think that's a wonderful proposal, because I think any project can benefit from formalizing the hypothesis, and that's great. I've added an orange post-it for your optimal subgraph definition, and then there are certainly other research questions you might want to work on. Who should go next, Andrew?
I don't think Jeff has gone yet.
Jeff, what's your research question? I'm not sure. You probably stumbled into the call.
I did, actually. I didn't even know this was going on, but I saw everyone in here, so I thought I would just drop in to see how things were going. But I don't have a particular research question, so I'll pass it to Angela in case there's anyone else who does.
Yeah, perfect. Thanks for joining.
Angela,
anyways.
Would it be okay if I jump in? I have to head to class shortly.
Yeah.
All right. Sorry, guys.
No problem.
Yes, I think throughout the previous sessions, I had a few different questions, and in particular, I think one of them was about really just the temporal features of quadratic funding or voting. So how does the time over people allotted to vote or actually fund a project impact their decisions in that sense? And the other question, I guess, I was just thinking about was just different kinds of functions besides like quadratic equations. How do those look like? And I guess I draw a parallel to sort of activation functions within deep learning or other machine learning algorithms. So I was curious to see how these equations, I guess, impact the decisions of people. So if you look at like the sigmoid function has like an upwards curve to a certain extent, and then it flattens out. So I was wondering if, for example, we apply this to the way people fund projects, if that would have any impact in a sense. And the other topic, I was just reading more about bonding curves, and it seems like there's a corollary between just the way that quadratic voting or funding works and how bonding curves are also modeled. And so I was just curious to kind of explore that a bit further.
Where can we find these sticky notes? I don't see them.
On the bottom left. The yellow ones, Irvin.
Okay.
Yep, right here.
Do we see it on the screen at the moment? I'm struggling. Maybe you can mark them, just activate them. Is this possible? Or even below now?
Do you guys see them? Or maybe I just click saved. Did that work?
Ah, there you go. They are here.
Okay.
Perfect. Thank you.
Yeah.
All right. Exciting questions. Thanks. It's up to you to choose who should go next. I think we have 1 or 2 people missing. Matt, I guess, and who else?
TJ Rush.
Yeah, I haven't spoken.
There you go, TJ. You're next.
Yeah, mine are the pink ones there on the side.
Okay, okay, all right, bottom right.
Right. So I think it was Sean, I believe, was talking about collecting metadata. And I find that really interesting, especially given that this data is on the blockchain. So I've written a piece of software called TrueBlocks, which lets me extract pretty much any data that you could possibly want from the blockchain. So I've already done a lot of work extracting. Gitcoin has always been sort of my test case for data. So I've already done a huge amount of extraction of metadata about the Gitcoin grants. While I recognize that it's important to keep that this is sensitive data, it's also on the blockchain, which means that it's totally transparent. So I want to think about how open this data actually is and what we can actually see in this data that maybe I think almost everybody doesn't realize how open it is, because I can see things that I'm certain people don't want me to see. So I'm kind of on a fence of being sensitive to people's privacy. I certainly think that's extremely important, but I think that the data is much more exposed than anybody really realizes. So that question to me is really important, and I think that we can help teach the community to be more hygienic about the way that they behave. And then I'm also just interested in what algorithm, how the match is calculated during the round, because I think that it seems to me that the match is very, very confusing to almost everyone as the round is going on, and maybe an explanation at the very least of how that's created and then why it kind of so wildly fluctuates during the round would be interesting. But I can help. I'm collecting this data, much more data than you could possibly ever want, probably. And I'm going to post it on IPFS, and I'll make that available to anybody that's interested in it.
Oh, cool. That's awesome. I mean, since I know that sometimes it's really a struggle to get on-chain data, and well, this makes our resource even richer.
Yeah.
Great.
Yep.
Awesome. We have 3 people left, I guess. It's Matt, Jonathan, and who else? Wyam. And Jan. Okay, Swayam, you're next.
Yeah, I think I have my sticky note on the top left.
Okay, let's try
So
to
it's
find
basically the correlation between recurring and
Mhm.
one-time funding, and which funding actually attracts more, which method
Mhm.
attracts more funding. And can we categorize projects according to the funding? So can we say that DeFi projects listed could have more, are generating more funding if they are listed in recurring, or if they are
Mhm.
generating more fund for one-time funding? I don't know. Probably
Mhm.
something on this line. But I really like someone mentioned that the correlation between how the quadratic funding works with the bonding curves, with how they are related to each other and how they impact each other. So that was
Mhm.
another thing that I really liked.
All right. And let's introduce all the notes you have taken. So who should go next? Matt is missing, Jonathan and Jan.
Yeah.
Jan?
Yeah.
I can basically go next then. Yeah.
Right.
So my posts are basically like the how can we model the Matthew effect in Gitcoin Grants?
Mhm.
And that's the first one. And the second one is how can we quantify the saturation effect on grant contribution behavior? So those are the two questions.
Mhm.
And yeah, I don't have a clear idea how to answer them. Like the first one, the Matthew effect, like as far as I know, is uh, like the chapter 5 from the network science book that is part of the reading material. That's kind of, but I don't know how deep basically anyone went into this kind of research and also how to relate that to the actual data.
Mhm.
Something that's not that clear. Like it's basically the preferential attachment theory, I think, right? And then the saturation effect, that's also something that's not very clear, but it's a very interesting question to ask.
Yeah. Cool. Thanks for sharing. Now, Matt, are you still there? Or alternatively, Jonathan? Jonathan, can you hear me?
Hello, hello.
Hello. Your sticky
Cool.
notes, your research question.
Hi, everyone. My sticky note has actually gone missing a little while ago, but that's fine
Maybe.
because my question is actually a subset of this question here, the one on the very bottom right.
Okay.
So, I'm most curious about what other sort of properties or metrics or visual giveaways there are of collusion. So, yeah, when 2 or 3 people ago, sorry, I've forgotten who it was, but who mentioned this question here. I just figured that my question was a subset of this one. So
Of which one?
that's the thing that I was the telltale differences between collusion and a naturally formed community.
Can you activate this sticky note so that I can find it faster?
It's the one on the very bottom right. What is activating?
Ah, okay. No, this one, isn't it?
Yeah, this one here.
Okay, cool. All right, good. Anything else?
Thank you.
All right, then.
That's it from me.
Oh, sorry. Go ahead. Sorry.
Sorry, I was just saying that's it.
That's it. All right. Then who is still missing? And what research question has been introduced?
Sorry, I didn't actually get access to. I missed the link somehow, but I was just thinking around how you might look at the impact
I can't hear you anymore for some reason. Just got the first part of the question, actually. Hello? Okay. Seems...
Can you... Hello.
Hello again.
Hey, it's Matt. I've been trying to talk for this whole time. I got computer problems.
Okay.
Okay, cool. Mine are the two in the top right, the purple ones. And they seem related to maybe like two topics we already talked about. So the first top right one, what's the efficacy of pairwise method for combating collusion? So Danilo was kind of saying that he hasn't really looked at that a ton. And then, like, is there a more extensible general method? So I guess this is sort of looking at like the security against collusion and stuff. And it seems to me like the pairwise method would be super easy to break. Like if you're a colluding attacker, like if you worked in teams of 3 or more. So that would be kind of cool to see if there's a more extensible, like general way to combat like group collusion. So I think that one. There was a group over here of, I don't know where it was. There was a group off to the left of like security-based questions. And then the second one is, can we develop a performance metric for the fairness of quadratic funding? And this goes back to sort of like the mission statement question of like, what is Gitcoin trying to optimize? But it'd be cool to know, like, could we come up with a mathematical metric of comparing sort of different collusion combating techniques or different tweaks to the model and say, oh, this scores higher than another method in backtesting or whatever. I think that would be kind of cool. Now I can't hear anything. I guess you guys can hear me, but I can't hear anything.
Yeah, sorry. This time it was because I was muted. Okay. That's it? Anything else from your side? No?
Nope, I'm good.
Okay, cool. Then for the last couple of minutes in this course, I'd like you to take this red sticky note, put your name on it, and then just stick it to the question you find most interesting. Of course, you can now cluster questions, and then let's find out if we have teams, if you'd like to work individually. Just pick whatever you'd like to go first with. Perhaps 8 weeks are enough to work on more than one question, but if you would need to choose, and you have to choose now, put your name and a sticky note on the question you find most relevant, and also where you think you really can produce output because you are capable to do so. Because you know, okay, I have a good picture of how to address this. Or I'm curious enough to find out. Okay, so everyone, Erwin, Jonathan, Jan, Mark, please everyone put one post-it with your name on a question you find interesting and want to work on. Jay, Sean.
So Lucid Charts is now telling me that I'm trying to access paid features. Is anyone else getting that?
What are you going to do? I mean,
I'm just
Yeah, I got
trying
the same
to
thing.
copy a sticky note.
Yeah, I'm getting the same as well.
that actually should be possible without having. Maybe they do it randomly and you just ignore it. It's not possible.
Well, I have the same issue.
Okay, so but that's a problem. I'll export this board so that you have access whether you use Lucidchart or not, and then you can check out the questions anyways. And what we need for Thursday is not the board itself, so yeah, that won't keep us from making the next step. And I guess you still know, Sean, what is most interesting to you and what you would love to work on.
Yeah, I'm thinking still. There's so many good ideas
Yeah,
here.
that's it actually. And I mean, there is Discord, so feel free to discuss and ping others where you think, okay, this question is really exciting and maybe very close to what I had in mind. Let's team up and work on it together. So that's the whole purpose of this group. Now, if you have made your choice now, or maybe want to have a look at it, a second look at it, or a third, no problem. What we are going to do tomorrow, first, there are two sessions. There's the academic session and there's the life hacking session. You can find this in the schedule. Tomorrow, February 18th at 6 or 12 Eastern Time, Gitcoin Model Collab, the live coding session, and 3.5 hours later, the academic session. And this academic session now is the chance to maybe sharpen your research question a little bit, define it, and then introduce it and get feedback from Gitcoin and Block.Science as well. And also Danilo hasn't had the chance to make any comments, but certainly he has comments. So this will be tomorrow, right? And we will have, I guess, 30 minutes of this 1 hour academic sessions to introduce the research questions so far. Correct, Danilo?
Yeah, correct.
Okay, cool. So, wait, let me share this. Can you see the HackMD, Danilo's HackMD? Do you see it?
Yeah.
I'm not sure. Yeah, okay, cool. So you can use this as a template. So copy it and now use it for formulating your own research question and also start with taking down your roadmap. So make a first overview on okay, what is this question all about? What's the target, the objective here? And then you might want to add first definitions, but that's not mandatory. In any case, try to formalize your hypothesis and then also add some more details on the methodology you'd like to apply here, right? These three elements. So a summary of the research question, your hypothesis, and methodology. If you want to, you can add definitions as well. And put it down in a document, share it on the Discord, and most important, share it tomorrow in the academic session and get feedback and then plan for next steps. Does that make sense? Questions? All fine? Then there isn't anything else. I'd close this session and then see you tomorrow. Thanks for joining. And thanks for the great presentations today.
Thank you,
Thank
Angela.
you.
Thank you. Thanks, everyone.
Thanks everyone.
Thank you.
See you tomorrow.
Thank you. See you tomorrow.
Bye-bye.
Thank you.
Bye.